Welcome to doassignment-ca. Here is the problem. A barrel barrier is placed in front of a bridge pier. The force deflection relation of the barrier is F equals 90 times 10 to the third power times x to the 1/2 power in pounds, where x is in feet. A car weighing 4,000 pounds is traveling at 75 feet per second just before it hits the barrier. Determine the car's maximum penetration into the barrier. Now, let us work through the solution step by step. We apply the work-energy theorem. T1 plus the sum of work from 1 to 2 equals T2. The car weighs 4,000 pounds and strikes the barrier at 75 feet per second. At maximum penetration, the car momentarily stops, so the final velocity is 0. The barrier force is 90 times 10 to the third power times x to the 1/2 power in pounds. We need to find the maximum penetration x max. We calculate the initial kinetic energy. The mass equals weight divided by g, which is 4,000 divided by 32.2, giving approximately 124.22 slugs. The initial kinetic energy is 1/2 times mass times velocity squared, equal to 1/2 times 124.222 times 75 squared, which is 1/2 times 124.22 times 5 and 625, giving approximately 349,369 foot-pounds. The barrier force opposes the car's motion, so the work done by the barrier is negative. We integrate 90 times 10 to the third times x to the 1/2 with respect to x from 0 to x max. The integral of x to the 1/2 is x to the 3/2 divided by 3/2, which equals 2/3 times x max to the 3/2. Multiplying, the work done by the barrier equals negative 60 times 10 to the third times x max to the 3/2 power. At maximum penetration, the car has stopped, so the final kinetic energy T2 equals 0. Substituting into the work energy equation, we get 349,369 minus 60,000 times x max to the 3/2 equals 0. Solving for x max to the 3/2, we divide 349,369 by 60,000 to get approximately 5.8228. To isolate x max, we raise both sides to the 2/3 power. The cube root of 5.8228 is approximately 1.8026, and squaring that gives approximately 3.249 feet. Therefore, the maximum penetration of the car into the barrier is approximately 3.25 feet. We verify by substituting x max equal to 3.25 feet back into the work expression. 60,000 times 3.25 to the 3/2 power equals 60,000 times approximately 5.861, giving about 351,660 foot-pounds. This is in close agreement with our initial kinetic energy of approximately 349,369 foot-pounds. The small difference is due to rounding. The answer is confirmed. The maximum penetration is approximately 3.25 feet. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.